Hello everybody. In this video we will look at the reactions. We will look at the formation of cyanohydrins. So cyanohydrin can be prepared. Again, it doesn't have to be ketone. I'm just drawing ketone for the sake of it. You can use aldehyde or ketone. They react exact same way. So we can make them. If we have HCN under slightly basic conditions. So when you have HCN, hydrogen cyanide, and under slight basic conditions, you're going to have some Cn minus that's available to react. So basically the Cn minus, where the negative charge is going to be on carbon, it will serve as a nucleophile. So now when you have nucleophile, this would go attack something positive. And we know that in carbonyl carbon, our carbon is delta positive and oxygen is delta negative. So this negative will run towards positive. And based on all the reaction that we have done, what should be our next step? What should happen to our pi electron here? It would move towards oxygen to maintain the octet. All right. So the intermediate that you will be forming is going to be CH3CO minus, CH3, and C triple bond. And it is critical. The carbon is attacking, not the nitrogen. A lot of time people write like this, like people wrote like, oh, people write like this, which is not correct. So if you write Cn all together, put the C under the bond and then write the N beside it. Okay. It's the carbon that's making the bond. Okay. So that's why I like to write the full form Cn. Okay, next step is, so this one, it can easily kicked out Cn to get back to this original form. So you will see this thing is in equilibrium, but let's move on. So our reaction is going to have HCN. So that's basically what it's going to do is it's going to abstract the proton to recreate the cyanide ions. So you can get CH3, COH, and CH3. And we already have our Cn right there. Okay, and then one of the byproduct would be Cn minus. And that Cn minus can be recycled for the next step of the reaction. So that's why you need just a catalytic amount of base to make these reactions move forward. Sometimes the book, some problems gonna have something like this: KCN plus HCl. It does the exact same thing. It's gonna generate potassium cyanide. It's gonna generate Cn minus. And then the HCl portion will neutralize the reactions. So it does the exact same idea. Okay, so why the cyanohydrins are important? Again, this is called cyanohydrin. Why this is important? Well, we could do plenty of reactions with this. So once you have this, so this is called hydrin because there is a OH group right there, and it's cyano because there is a cyano group here. So if you have CH3 C triple bond N, and once you make this, you can do reduction. So you can use the reductions, lithium aluminum hydride with H3O plus. So two-step reductions. This is something we will talk about in the next chapters. That's basically reduce the Cn bond. So how can we reduce the Cn bond? We can reduce C triple bond N. Okay, so reduction means addition of hydrogen. So the triple bond is going to be gone. Now it's going to be all single bond. Now, how many bonds more needed for carbon? 2 more. how many bonds more needed for nitrogens? 2 more. And we're just going to add hydrogens, hydrogens, and hydrogens. So this is a great way to form an amine to make this ones. Another thing we could do is, if you hydrolyze this, the mechanism we will study in the next chapters, if you hydrolyze it, it's going to form the exact same thing. CH3, C. Now, before it had 3 bonds connected to nitrogens, right? Now, all of these bonds will be gone and it's going to be hydrolyzed to make carboxylic acid. So again, these reactions are important in scheme of multi-step synthesis. With the mechanisms we will talk about in the future chapters, but just know that these reactions exist. So the key idea here is the reaction of aldehyde or ketone with the cyanide ions. The reaction follow the exact same pattern, where a nucleophile attacks on carbonyl carbon, and then once you have the O negative ion, we just neutralize it, a proton source. Okay, that's it. Let's stop here.